Welcome back to All This Math. This is Professor Parker. Please make sure you're subscribed to the All This Math YouTube channel. Make sure you like this video. Make sure you drop a comment down below and make sure you share this video with somebody else. All right. So, what are we getting into now? We're going to do some division using the partial quotients method. That's what we're about to do. We're about to do division using the partial quotients method. All right. Now, what does that mean? Well, first off, what does division mean? I don't want to take nothing for granted. I want to make sure we understand what division means. Division can mean a few things. One of the things it means is how many of the second number can fit into the first number. Again, how many of the second number in the division problem can fit into the first number? How many of the divisors can fit into the dividend? The first number in the division problem is called a dividend, right? Or a division equation. It's called a dividend. The second number is called a divisor. Dividend, divisor. Dividend, divisor. And the answer is called a quotient. Dividend, divisor, quotient. So the quotient is how many of the divisor can fit into the dividend. So how many 85s can fit into 164,135? All right. Now we're using the partial quotients method. Now, why is it called the partial quotients method? Because what we're doing is we're taking the dividend and we're breaking it up into smaller parts. And then we're doing division with smaller dividends. So smaller numbers. So partial quotients, not the whole quotient at once, but parts of the quotient. And then we're going to add up those parts to get the total quotient or the final answer. All right. Now, a lot of us might be familiar, especially if you're a parent watching this, you're probably familiar with the long division method, which is like the standard algorithm for division that we learned when we was younger, right? This is not long division. This is related to long division, but it's not long division. It actually it's an alternative method that I actually like a lot. Once I learned it, I didn't learn this when I was in elementary school though, but I dig this method a lot. So, all right, so now we got 85 as our divisor. You write it out here. So if you're setting up a problem like this at home, it kind of looks like, the game we used to play in elementary school back in the day, Hangman a little bit. So you got it looks like a long division symbol, except you got this vertical line right here. This vertical line that looks like the y-axis, right? On the other side. We're gonna talk about the y-axis when we start talking about some algebra 1 problems. All right. I got some videos about that on this channel too. Make sure you lock in. All right. So now this is the dividend, 164,135. All right. Now, again, we're not doing long division. We're doing partial quotients method. So what we're going to do is we're trying to figure out like 85, how many 85s can fit into a number that's close to this number, right? Because we don't know if 85 can fit exactly into 164,135. We don't know that, right? It might be the case, but we don't know that. So let's say this. Let's say in a situation like this, we might say, well, what's 85 times 10? 850. That's not that close to this number. What's 85 times 100? 8,500. That's not really that close to this number. Remember, this number is 164,000. What's 85 times 1,000? That'd be 85,000. That's like half of this number, right? But then what's 85 times 10,000? That would be 850,000. So that's too big because that's more than this dividend. So we never go above the dividend. Again, we never go above the dividend. Again, we never will go above the value of the dividend. All right. So 85 times 10,000, that's too big. 85 times 1,000, we could rock with that, right? 85 times 1,000. So what is 85 times 1,000? Anytime you multiply a number by 1,000, all you're doing is simply attaching the 3 zeros from 1,000 to the original number. So our original number was 85. So we're attaching the 3 zeros from 1,000 to the 85, giving us 85,000. Now, where do I write the 85,000? I'm going to write the 85,000 right here. Matter of fact, let's use a different color. Let's use a different color. All right, let's do this. Let's do 85,000. All right, and then out here, I'm going to get real creative. Let's do red, black, and green, like the African liberation flag. All right, so now 85 times what gives me 85,000? 1,000. So I'm going to put a 1,000 out here. All right, so I got my 1,000 out here. So then what I'm going to do is I'm going to subtract. So this is similar to long division where you subtract, right? As one of your steps. So we're going to do, so we need to know how to subtract. You got to know how to subtract. You could use a calculator for this, but you should make sure you know how to do this manually also, which may require you to regroup, which is cool. We're going to talk about that. So we start from the far right. 5 minus 0 is 5. 3 minus 0 is 3. 1 minus 0 is 1. 4 minus 5. Okay, using this method that I'm using, the traditional method algorithm, our top number needs to be larger than our bottom number. So I'm going to borrow from the 10,000s place. I'm going to take 10,000 from this 60,000. This 6 represents 60,000. I'm going to grab 10,000 from that 60,000, right? So then this is going to become 5 or 50,000. I'm going to take that 10,000. I'm going to give it to the 4,000. 10,000 plus 4,000 is 14,000. 10,000 plus 4,000 is 14,000. So that's why when you borrow, this 4 will turn into a 14 because it's really representing 14 thousands. 14 thousands. That's why it's 14,000 because we took 10,000 from the 10,000s place. We had 60,000 right there. We took 10,000 from 60,000. 10,000 from 60,000, right? Leaving us with 50,000. That's why there's a 5 here now. Now, again, this is a 5, this is an 8. Using this method, I need my top number to be bigger than my bottom number. So I need to borrow from the 100,000s. All right, so I'm going to take 100,000 from here, right? I'm going to take 100,000 from here and give it to the 50,000. All right, so 100,000 plus 50,000 is 150,000, right? That's 15 10,000s. Think about it. Understand this concept. 150,000 is the same thing as 15 10,000s or 10,000 15 times. That's why this 5 is going to turn into a 15. This 1 is about to turn into a 0, but this 5 is going to turn into a 15. Because look, what did I do? I took 100,000 from that 100,000s, please. It was only 100,000 there. There's only 100,000 there, right? So now we got that 100,000 is gone, right? And then we're going to take that 100,000, put it with the 5,000 that was there. 100,000. No, I'm sorry, that's not 5,000. It's 50,000 because it's in the 10,000s place. 100,000 plus 50,000 is 150,000, just like with money, 150,000. But how many 10,000s is 150,000? That's 15 10,000s. 15 10,000. That's a concept that we have to understand when we're not only when we're doing subtraction like this, but when we get to higher level math, because we have to understand place value and the base 10 system. We got to understand those relationships between the numbers and the different place values. We got to understand that. People end up looking silly out here all the time and making poor estimates because they don't understand place value in real life. All right, we got to understand place value. So now we can subtract because we got a 15 up top and an 8 down the bottom. Well, actually, no, over here. We ain't subtract here. We got a 14 up top and a 5 down the bottom. 14 minus 5 is 9. 15 minus 8 is 7. So we got 79,135. All right. Now our goal is to get down to 0. We started with this original dividend. We're trying to get to 0, right? Or as close to 0 as possible because we might end up with a remainder. But as long as we're as close to 0 as possible, that's cool. All right. So now we're going to figure out 85 times what will get us close to 79,135. 85 times 10 is going to give me 850. That's not close enough. 85 times 100, 8,500. That's not close enough neither, really. 85 times 1,000 is 85,000. That's too large. But what if I go back to 85 times 100? But what if I do like 85 times 200, or 85 times 300, 85 times 400, 500, 600? Let's see what happens. Now, this is how I'm going to estimate. I'm going to act like this is 80,000. I'm going to round this up. Act like it's 80,000. And then I'm going to say, all right, well, if this was 80,000, how many 85s can fit into 80,000? 85 times 10 is too many. 85 times 9, that's probably too many also. Let's say 85 times 8. 85 times 8. Let's see what happens. Because 85 times 8, and that's not really 8, it's really 800. 85 times 800. All right, it's going to be 85 times 800. So let me draw my line right there, put my minus sign because I know it's going to go here. So this is what's going to happen. We're going to do 85 times 100. I'm going to put my 100 out. And this 1,000 right here, this 100 right here, these are what we call partial quotients. Partial quotients. They're part of my final quotient. And actually, no, we didn't say 100. We said 800. So let's do 85 times 800. Now, mental math, the way I do 85 times 800 is using the distributive property. I'm gonna break this 85 down into 80 and 5. 80 and 5. 80 and 5. I'm gonna do 80 times 800. So I do the 8 times the 8, that gives me 64. And then I got 3 zeros. Because the zero, remember, I broke this 85 down into 80 and 5. 80 and 5. So I'm temporarily acting like that 5 isn't even there. But with the 80 and the 800, how many zeros is that all together? That's 1 plus 2, that's 3 zeros. So that's 64 with 3 zeros next to it. 64 with 3 zeros next to it. So we got 64 with 3 zeros next to it. That's 64,000. So that's 64,000. But then you got the 5 times the 800. 5 times 800 is 4,000. Right? So 64,000 plus 4,000 is 68,000. So now I got 68,000. All right, 68,000. I know somebody might be saying, why we got to do all this? This seems harder. This is harder than long division. It might be, and it probably is if you've never seen it before. Usually, whenever you see something for the first time, it's going to be real difficult. Trust and believe, it's going to be very difficult. When you become used to it and accustomed to it, you've done it like 30 or 40 times, then it's not so difficult no more. So seeing something for the first time and feeling as though it's difficult is not a reason to not do it. That's actually illogical, because anything you know how to do, it was more than likely difficult the first time you did it. And if you just gave up and said, well, what's the point of me doing this? Then you actually wouldn't know how to do almost anything, because that means you would have quit on everything that was ever difficult. And then we got to think about a deeper issue. Is it that we don't like hard work? We run away from difficulty? Remember, you can't grow without difficulty and hard work. So is it that we don't really want to grow as people? This is deeper than math. This is about life for real. Just keep that in mind. So, all right, 79,135 minus 68,000. So now we're going to do our subtraction. So now we're going to do 5 take away 0, right? Which is 5. We're going to do 3 take away 0, which is 3. We're going to do 1 take away 0, which is 1. We're going to do 9 take away 8. That's 1. Then we're going to do 7 take away 6. That's 11. So we got 11,135. Right? 11,135. All right. So now I got, let me see. So now I got 85, and I'm figuring out how many 85s can fit into 11,135. All right. 85 times 10 is 850. I want to get closer. I want to get closer to this number. Right? This is like what we can call my partial dividend, right? My partial dividend, my original dividend, partial dividend, right? We can call it that. Now, what about 85 times 100? That's 8,500. That's kind of close, because if I do 85 times 1,000, that's way larger than this, and we don't want that. And if I do 85 times 200, that's going to be 17,000, which is more than this. Let's do 85 times 100. Let me do my minus sign and my underline. And then we're doing 85 times 100, right? And why am I doing 85 times 100? Because that's going to give me 8,500, which is less than this number right here, this partial dividend. So I'm going to put 100 right here. That's another partial quotient. I got 3 of them, right? Now remember, we're trying to get this number as small as possible, right? Or the dividend is as small as possible before we go on. So what's 85 times 100? Take the 85, attach 2 zeros. Why 2 zeros? Why not 3 zeros? Why not 4 zeros? Because 100 got 2 zeros in it. 100 got 2 zeros in it. So we attach 2 zeros to 85. 1,000 has 3 zeros in it. So we attached 3 zeros to 85. Right? This is a little different because we ain't multiplied by a power of 10. This is 800. This is 100 times 8. So it's slightly different, not all the way different. But anyway, so we got 8,500. So we got 8,500. So we're subtracting. We got 11,135 minus 8,500, right? So now we got 5 take away 0, which is 5. We got 3 take away 0. We got one take away 5. Using this method, my top number needs to be bigger than my bottom number. So I want to do something different. I want to I'm gonna borrow or regroup. We actually shouldn't say borrow. We're not really borrowing. We're regrouping. So I'm gonna go to the 10th. I'm gonna go to the thousands place. I'm gonna take 1,000. I'm gonna take 1,000, right? Just like, if you got a bank account, right? You got a checking account, you got a savings account. You might have to move some money around. You know what I mean? Because a bill might have came up. You got to move some money around. That's all we doing, right? It's all your account anyway. It's all your money anyway, right? Supposedly, right? So I'm going from, I take 1,000 from the thousands place, move it to the hundreds place, right? So now if I take 1,000 from here, how many thousands I got left? I got none. Because if you got 1,000, you take that away and move it over here. You got none left over there. What's 1,000 plus 100? That's 1,100. So how many hundreds is that? What does it sound like? I just said 1,100. How many hundreds is that? That's 11 hundreds. 1,100 is 11 hundreds. All right. So that's why this becomes an 11. That's why it becomes an 11. That's the concept. That's why it becomes an 11. All right. So now I can do 11 minus 5. 11 minus 5 is 6. Then I go here. Oh, 0 take away 8. I need my top number bigger. So I go to the 10,000s place. I'm going to take 10,000, and I got none left now, 10,000, and put it over here, right, with the 0 10,000. So 10,000 plus no 10,000s leaves me with 10,000. Again, 10,000 from the 10,000s place. If you match that up with 0 10,000s, that leaves you with 10,000. So how many thousands is that? How many thousands is 10,000? 10. 10 thousands. That's how many thousands. So then you got this right here. Boom. We got 10. And now we got 10,000. Take away 8,000. That leaves me with 2,000. So we got 2,635. We're getting close. We're getting close to zero. Getting close to zero. Now, how many 85s can fit into this number? 85 times 10 is 850. 85 times 100 is 8,500. So we're not going that big. We're not going that big. Right? We're not going that big. That's too large. That's too large. Right? Boom, subtraction sign, underline. All right. So now 85 times 10 is 850. What if I double that? What's going to happen? Or if I triple it? If I double it, that's going to give me like 1,700. What if I triple it? Let's see what happens. 85. What if I doing mental math? I break 85 down into 80 and 5, 80 and 5, 80 and 5, 80 and 5. 80 times 3 is going to be 240. 240, 80 times 3, but it's 300 though. It's 300. So that's 240 attached to 2 zeros. That's 2,400. No, that's 2,400. 240 with 2 more zeros. Hold on a second. 80 times 3. 85. 85 times. Oh, nah. You know what? Hold on a second. 85 times 100 is 8,500. Right, we're not doing 100. Times 10. Okay, 85 times 30. 85 times 30. Right. So 80 times 3 is 240. Attach 1 0. 80 times 30 is what I'm trying to do. Right? But first I do 80 times 3. I'm trying to do 80 times 30, but I do it in parts. I break it down in parts. 80 times 3. So I'm trying to do this, right? 85 times 30. So I do this. I do 80 plus 5 times 30, right? So then I do this. I do 80 plus 5 times 3, right? And then I'm going to multiply that by 10, right? So what's 80 times 3? 240. What's 5 times 3? 15, right? And then what's 240 plus 15? 255, right? Now, but this is times 3, right? We wanted to multiply by 30. So we dropped this 0 off. We got to bring this 0 back. That's why we get 2,550. 2,550 because this 0 from the 30 got left off. All right, so 85 times 30 is going to be 2,550. So we got 30 right here. So then I got, again, red, black, and green. Black power flag. I should say African liberation flag. So we got 2,550. Now we subtracting again. Start from the right side. Standard algorithm. What's 5 minus 0? That's 5. What's 3 minus 5? Gotta borrow. Because we need, regroup. We want the top numbers bigger than the bottom numbers. We want to be top heavy. We doing this. We want to be top heavy. That's what we want. We want to be top heavy. All right. Top numbers bigger than the bottom numbers, like somebody with a big back. Right? Top heavy. All right. So 3 take away 5. We're going to borrow from the hundreds place. I'm going to take 100 from this 600. I'm going to take 100 from this 600. Right? And then that's going to leave me with 500. That's what that's going to leave me with. It's going to leave me with 500. You take the 100 and you give it to the 30. 100 plus 30 is 130. How many tens is that? 130 is the same as 13 tens. 130 is the same as 13 tens. Think about money. 13 $10 bills is $130. So this 3 is going to become 13. So then we got 13 take away 5. 13 take away 5 is 8. And then 5 take away 5 is 0. And I didn't even need to write that 0. Well, you know why? Because 2 minus 2 is 0. So that means this 0 was unnecessary. So now we left with 85. So look what's about to happen. We left with 85. So 85, how many 85s can go into 85? 1. 1. So boom. And that's going to be up. My color's off. Nah, got to stay consistent. Got to stay consistent. Got to stay consistent. So we're going to have 85 right here. We subtract. We're going to have 85. Take away 85 is 0. And then how many 85s can go into 85? 1. Uno. Now, how do you get your answer when you're using the partial quotient method? You take all this is a partial quotient. 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 Sometimes you're going to get a remainder. How do you know when to stop? So if you don't end up with 0, if you end up with a number that is less than your divisor, that's when you know to stop. For example, if we had ended up with 79, am I saying that right? Yeah, 79 is less than 85. So that means that 79 would be our remainder. So that's how you know when to stop. Either you end with a 0, right? Or you end with a number that's less than your divisor. Once you get to a number that's less than your divisor, it's either going to be 0 or it's just going to be less than the divisor. That's how you know when you're done using the partial quotients method. That's how you know when you're done. All right. So how do we get our answer? We add up the partial quotients. Partial means part. Add up all the parts and see what you get. So we got 1,000 plus 800 plus 100 plus 30 plus 1. That gives us 1,931. 1,931 is an important year. You know why? Because that is the year that the late Toni Morrison was born. I don't know if you're familiar with Toni Morrison. Professor, writer, editor. She actually, see, there's a reason I wore this hoodie, my Black Power hoodie, because Toni Morrison not only graduated from Howard University, but she also taught English at Howard University. And actually, she was one of Kwame Ture, the late Kwame Ture's English professors at Howard University. And when he co-authored this book with Charles V. Hamilton back in 1968, Black Power, the Politics of Liberation, right? Toni Morrison worked for the publishing house that was publishing it, and she edited this. So she's connected to Black Power, right? She was the editor for this book, right? She also wrote, and that's probably like not as popular of a fact about her, but she's probably more well known for her books such as The Bluest Eye, um, Song of Solomon, Tar Baby, Beloved, Zula, I think is one of them. What else? What else? What else? What else? Yeah, it's a bunch of them. It's a bunch of them. I'm doing her a disservice by not naming. I mean, she wrote a lot. She wrote a lot of books. Um, The Bluest Eye is actually the only one of her books I've read. I do plan to read the Song of Solomon. I do plan to read that. That got good reviews. Yeah, that's I do plan to read that. But again, we did a math problem, partial quotient division. We ended up with a number that's important, right? 1931 or 1931. That's the birth year of Toni Morrison. Her birth date is February 18th, 1931. So I know partial quotients method seems like a lot. Every problem is not set up like this, though. Every problem doesn't involve this much. This problem involved a lot because our divisor was only a 2-digit number and our dividend was a 6-digit number. So we had to go through a lot, had to think a lot. But thinking is not a bad thing. We should challenge ourselves to think, right? So we can figure stuff out. Because young people, old people, adults, we need to know how to figure stuff out. Black people need to know how to figure stuff out. We got to know how to figure stuff out. I got to know how to figure stuff out, or else we won't survive. You have to know how to figure stuff out. Math is a great opportunity to practice figuring stuff out. And the stuff you do in a math class is not limited to math class. Figuring stuff out is a life skill. So what better way is there to get practice at just figuring stuff out when there's low stakes involved, right? Sitting in math class, doing a math problem, having to figure stuff out. It's okay to make mistakes. In the real world, sometimes you can't make mistakes in real life. Sometimes the consequences are too serious, right? So practice the math. The more difficult, the better. That's what you want because you want to learn how to figure stuff out. Don't run away from it like a lot of people are going to urge you to do. Don't do that because then you're going to grow up and if you're a child watching this, you're going to grow up and you're not going to know how to do nothing. And you have to find somebody that's going to do stuff for you. You don't want nobody to have to do stuff for you. You want to be able to do it for yourself. You need to know how to figure things out. You need to know how to think critically. You need to know how to understand things, how to make decisions, how to analyze and critically assess situations. You need to know how to do that. Mathematics is a great practice for that. So if you was watching this thinking, I don't really know how to do this, the beauty of it is you can hit rewind, run the video back, run it back, any parts you didn't understand. All right. And then just go make up some other problems and try to follow along. All right. So anyway, that's the partial quotient method. Shout out to the late Toni Morrison, and I'll see y'all on the next video. Hopefully you're subscribed. Peace.